So that's the actual create. Now let's talk a little bit about our bid function. So first, what I'm going to do is I'm just going to simply, using the same account that created the auction, let's say I changed my mind and, hey, I actually want this asset. I'm going to go ahead and bid. So I'm going to click the bid button. I set my bid for 20,000 micro algo. So we can now see I'm sending 0.02 algo and calling this application. And do a confirm all. It's going to send the bid, and then the bid has been sent. And so now we can see, if we take a look at our app, our global state has been updated to now have a new highest bidder and what the highest bid was. So let's take a look at what's actually going on here. So when we click bid, instantiating our sender just like before, updating our status text, we're making a suggested params object that has the double fee override. And then we're going to go ahead and make a payment transaction. So this payment transaction is going to be the actual bid itself. And then we are going to, let's say the amount is whatever the amount input is. So whatever we typed in here, it's coming from our sender. So whatever address we have selected here. And then it's going to the address of our application. And that's going to be our payment transaction. Now, the next thing we're going to do, so I'm just going to delete this momentarily while I talk through what the code's doing, and then I'll talk a little bit about it afterwards, is it's going to go ahead and read the state from our application. Now, the reason we want to do this is if we take a look at our app.py, when we call def bid, we need to figure out who the previous bidder is when we call the transaction. Again, the reason we need to specify the previous bidder here in the arguments is so that the AVM knows that it's going to be accessing this account and that it needs to read this account into memory before we send the transaction or before it evaluates the transaction. So in our method call, when we eventually want to call our bid method, we need to make sure that we're passing in the previous bidder as an argument. So the question is, how do we get our previous bidder? And the answer is read our state. Excuse me. So what we basically want to do is, as a human, in order to know who the previous bidder is, we simply go on our Explorer, take a look at this app, see what address is in the highest bidder. Now, how do we do that programmatically? What we want to do is we first want to get state from our application. So we do this by calling algod client, get application by ID, and then pass in our app ID. And what this will do is get all the information about the app that we may want to know, and then call .params global state. What this is going to do is get all of our global state from our contract. Now, I think deleting that comment, oh no, okay. So I'm not going to go ahead and change the code right now, show you this, but basically, when we get our global state, it's going to be in a unreadable human format. It's going to be all base64 encoded. It's going to be unclear whether it's supposed to be bytes or integers. So what we really want to do here is call our utils.getReadableState and pass in our state object. What we're basically doing is we take a look at what getReadableState is doing. It's getting an array of state, and this is what it looks like. It has a key and a value. The key is base64 encoded, and our state value has an action key, a bytes key, and a UN key. So it's hard as like an end user to just make sense of what that's all doing. So what this getReadableState is doing, it's taking in the response here from our algod client. So the response from get application ID, and then our global state key. And then it's going through iterating over all of our keys and decoding it. If it's bytes, it will decode it as both an address and a string that will be accessible to us. Otherwise, it's just going to get the number by encoding it as or by getting it from the raw value and then encoding it as well if we want the raw number. So we can see here that get readable state utils readable state. And what we want to do is from our readable state is get the address of the highest bidder. So we're going to call readable state dot highest bidder. And because this is a bytes, we want to call dot address. So here you can see we just did highest bidder. We'll have a couple of different options to choose from. In our case, we know we're going to be getting an address here. So we're calling dot address. But if this value is empty, and I accidentally just reset the, oh no, I didn't. If this value is empty, so if our address was empty and there hadn't been a first bid, what this will basically do is just default to the sender address. And this is basically saying don't pass in any particular unique value here because we're not going to be using it. And again, the reason we need to do this is in our bid function, we're passing in the previous bidder because if there is a previous bidder, we want to return that bid to the highest bidder. So we want to make sure it's the correct address here. So now that we have our previous bidder function, we're ready to actually call the method. So we're going to do ATC, a new atomic transaction composer, and then do ATC add method call, pass in the auction app ID, pass in our Algo SDK.get method by name, and then we're getting our bid method, and then we're passing in our payment transaction. So the actual like bid transaction itself, and then our previous bidder, then passing in our sender and signer as usual. And then call atc.execute, and then we'll update our status. So now we can see here, what we've done is, we need to look at our most recent transaction here. Take a look at this group. So we've done two things. A, we sent 0.02 algo. And the reason we did that is because we wanted to fund, or that was the actual bid that we were sending. So here in our front end, we said 20,000 micro algo, so that's 0.02 algo. And then we actually called the app ID, and this is going to be the actual bid function call. And you can see here that it updates our highest bid and our highest bidder as well. So now if we take a look at our app, we can see we have our highest bid, our highest bidder, and our global state. And now what I'm going to do is if I send another bid, so let's send a bid of 30,000 micro algo, and I go ahead and sign that transaction and send it to the network. We can now see if we refresh that our new highest bid is 30,000. And since it's the same account, the highest bidder didn't actually get updated, but we can take a look at the group here, and we can now see an additional transaction was included in the group. So first we have our bid of 0.03 algo or 30,000 micro algo, but we also have our app call. And in that app call, we have an additional transaction, which is 0.002. So taking a look at what that transaction actually is, it's an inner transaction from the app itself to the previous highest bidder. So what that transaction actually is, because now that we've had a previous highest bidder, we execute this pay function, and that's what sends that inner transaction. So now we've gone ahead and we've implemented all of our core functionalities in terms of actually interacting with the auction contract. Now, one thing you might notice here is that we don't have our claim bid and claim asset functions integrated into our front end. And the reason being that we don't, I actually forgot to do this before deploying, but basically when we deploy to testnet, we'd want to make sure that we've uncommented these lines. And that's because we've commented those out for automated testing. And when we deploy on testnet, we want to make sure that those things are actually true. And so now what we're basically doing is saying that don't make these methods callable, claim date and claim asset. Don't make them callable until we have our auction is actually over. So we don't have that implemented at the front end. Again, this was just going over the core functionality of our smart contract.